Hello and welcome to this episode of The Daily Space for today, September 26th, 2019. It is a Thursday that some are reporting seems to be acting more like a Monday. I understand that there are a certain amount of technological difficulties currently going on with Twitch. This is most likely in relationship to new features that are getting launched to coincide with TwitchCon this weekend in San Diego. I can tell you we will take advantage of as many of the there was bits. Did I forget audio or something? Twitch day, patch day. No, just random bits. Okay, I'm good with random bits. Often in the beginning of episodes when I see that, it's because I've muted audio. Yes, you can have that. Thank you so much, Keeper. Thank you, Wayne Johnson. Okay, so this weekend is TwitchCon down in San Diego. I am not attending this year. I will be going next year. We will be taking advantage of many of the new technologies as they come out, when they work. But for now, all of us together are going to have to endure some of the, features getting added and sometimes breaking what exists on this platform. But for now, we have astronomy news. Now, this morning when I got up and opened my press release folder, I was faced with a shock and awe wall of embargoed science-y goodness. And only one thing can be responsible for the vastness of what I faced, and that was a new episode of Science Magazine is coming out, and there's going to be a whole lot of astronomy in it. Unfortunately, that embargo ends, 57 minutes from now. So I can't discuss any of the science-y goodness that I was able to read through this morning. But I can let you know, tomorrow's going to be awesome. But for now, I may not be able to share that science-y goodness, but there is a variety of science that is coming out that I can talk with you about today. And our first story is one that takes us to the nearby asteroid, not too nearby, but on the scale of today's science, nearby asteroid Psyche. This particular asteroid is considered to be the largest of the nickel-iron metallic asteroids. This particular rock is about 200 kilometers across, and it is so massive that it is able to change the path of other asteroids that approach too close. It is because of its very awesome ability to move things around in the asteroid belt that we are able to actually measure the, total mass of Psyche. And when we put together its observed mass with its observed size, we can actually get at its density. And what we were expecting, because it reflects light like a nickel-iron meteorite, is the density of a nickel-iron meteorite. But that's not what we actually see. What we actually see is a much lower density. And this has been one of those confusing things that, is why we keep doing science, because we want to try and figure it out. And in a paper that just came out, there is information, and here I'm going to look to see. This is a paper appearing in the journal Nature, led by Brandon Johnson. There are new models put forward that postulate that the way you get something like Psyche is you start with a large asteroid that when it's still young and hot and molten, which basically means squishy liquid rock, it undergoes a process of differentiation where the light rocky stuff rises from the surface, the heavy metallic stuff sinks to the center. And as it cools from the outside in, you end up with a rocky shell over a molten metal core. And as the pressure builds up, as the heat builds up inside, you can end up with ferrovolcanoes and ferric volcanism. What this means is we have a new kind of volcano to discuss. We knew about the regular volcanoes, just called volcanoes, like we have here on Earth and like have been seen on Mars, where you get what are called basaltic materials, molten lava that comes out and spreads all over the surface of a world. We have also seen cryovolcanoes. This is where icy materials get ejected out or liquid gets ejected out and very quickly freezes. Well, in the case of ferric volcanoes, you get liquid metal coming out and essentially providing a hard coating to the surface of an asteroid. So this model postulates that Psyche is one of these differentiated asteroids with a metallic core and past ferric volcanism that is covered in metal like hard shell on ice cream. And what's awesome about this particular model is it's able to explain some of the meteorites that we see here on Earth that don't entirely make sense. Pallasites are one of the most beautiful forms and most fragile types of meteorites that you can get that are still metals. And the material in these pallasites appears to be a mixture of materials that are common both in the crust and mantle of differentiated asteroids. Well, if you have active volcanism going on, you can get a mixing of materials from different layers within an asteroid. So this model doesn't just explain what we see at Psyche, but it also explains pallasite meteorites that you can buy at your local gem and mineral store. So this is a pretty cool model, and it's the kind of model that we should be able to hopefully prove or disprove in the coming years as we look to send new missions out to explore at Psyche. Now, continuing our journey outwards, I'm realizing I do not have my mouse, so I cannot advance to the next slide. I'm going to grab my mouse. One of these days, I'm just going to break down and get a second mouse for down here, but today has apparently not been that day. So moving on. Oh, and I accidentally clicked something. There we go. Moving on to our next story. This is one that is certain to attract much attention in the news because it is a story of a star being, well, the official phrase is tidally disrupted by a supermassive black hole. Put in plainer language, this star got a little too close and got shredded, at least in part, by a supermassive black hole. This particular event occurred far, far away. It occurred 115 megaparsecs away and was detected using one of our, well, all-sky supernova searches. So with robotic telescopes spanning the world, technology, not people, are out there every night looking for that thing that flares up in brightness. And often these are stars that, for whatever reason, have exploded due to internal processes. Well, in this case, it wasn't so much that the star got exploded as it got shredded. And this discovery, coincidentally, was in the area on the sky that is being constantly monitored by the TESS Observatory. And this flying telescope orbiting our planet has extremely high quality imaging capacities and was able to observe. It was already observing this field roughly every 30 minutes. And because of that cadence and because the data goes back many months, they were able to look at the data, see that the object had begun to brighten more than 8 days before the supernova survey identified it. And with the triggering that occurred with the supernova survey, They were able to get data from a variety of other orbiting observatories that were looking at this object in ultraviolet, high energy X-rays, and gamma rays, and putting all of this data together. They were able to say, yes, this is a star that got shredded, and they were able to study the detailed physics of, well, how a black hole goes about feeding on something. Now, this is one of those rare events that we know happens and we just don't see very often. It's estimated that a galaxy like our own Milky Way galaxy will eat a star roughly every 10,000 to 100,000 years. This means that if you want to see one event, you need to look at 10,000 to 100,000 galaxies for an entire year. So yeah, these are rare, and this is awesome data across many wavelengths. And I'm sure that all of us are going to be figuring out how to download this paywalled paper and read it in detail in the coming days and weeks. Now, from one high energy event to another, our next story is a story of galaxies not yet gone wild, but that will someday in the future. One of the things that we're constantly trying to understand is how supermassive black holes in the centers of galaxies grow over time. And it's believed that when galaxies merge, the supermassive black holes of the two merging galaxies should merge together. We haven't seen this happen. And part of trying to understand this process is just finding these systems. And the Sloan Digital Sky Survey makes this possible. And astronomers working with citizen scientists have plowed through the Sloan Digital Sky Survey and identified a whole variety of systems that appear to be merging galaxies. And following up on these systems with the Chandra X-ray Observatory, they were able to see the specific high energy light that says this is a supermassive black hole and this is a supermassive black hole. And in this one particular system, they said it 3 times. Now, what makes finding a 3 supermassive black hole system particularly interesting is models looking at how 3-body systems interact with one another indicate that by having 3 supermassive black holes instead of 2, you should be able to get 2 of the supermassive black holes to merge significantly faster. And that's just kind of awesome. It also overcomes problems with how do you prevent them from ending up in a stable orbit, or at least one where the various physics are preventing them from making it that final parsec and merging all the way in together. Now, again, we don't know how common these kinds of things are. And by looking at a massive catalog of systems of merging black holes and going, this one's 2, this one's 2, this one's 2, this one is 3, we can start to figure out how frequent these kinds of events are. And by knowing the frequency of these 3-body systems, it starts to allow us to make predictions about how often future gravitational wave detectors like the on-orbit LISA that will be launching in a few years, how frequently they'll be able to detect the mergers of supermassive black holes, not just black holes, not neutron stars, but supermassive black holes once they come online. So that was it for today's news. It's a kind of slow news day. Tomorrow, oh my God, tomorrow, so much more than compensates. And for now, though, I'm going to struggle to make this work. For now, though, I am going to take your questions. So I'm going to look through the chat and see what all you have asked, and go ahead and type your questions in now if you haven't already, and put in front of the question that circle with a star inside of it. While you're typing them in, I'm going to go ahead and remind you This is the Daily Space, and I am today's host, Dr. Pamela Gay, but I'm not the only person that goes into making this stream possible. We also have my co-host, Annie Wilson. We are produced by Susie Murph, and of course, we are a product of the Planetary Science Institute, a 501c3 dedicated to exploring our solar system and beyond. We are here because of you. We are here thanks to your bits, your donations, and your patronage over on patreon.com/CosmoQuestX. If you can't support us financially, we get it. Just spread the word. Can you do that? One of the best things you can do for us is just help get other people consuming our content. You never know whose life you're going to change by giving them science. And you will change us by getting more people viewing. Search engines are optimized to show people the most popular shows. And that means every time you look at us, you make it more possible that someone else will look at us. So share, please. Okay, I'm going to go ahead and look for some questions. Let's see. So much love for Nightbot. So much love for Nightbot. Yes, Wanning Sky. We were talking about the asteroid Psyche. Psyche is a girl out of mythology. She is also a iron nickel meteorite. Sometimes the answer is both. And my computer just made a very exciting noise, and I don't know why. Okay. Looking for questions. There are no questions that I can find. Hello, Waning Sky. No questions at all. Is it just going to be a short day today? You're all just psyched. Hey, Daddy Cupcake. Hello, DPI209. Hello, Falco Online. Yes, you did miss the news. It was a short news day today. So Just for Must asks, how long does it take for us to catch the gravitational shock produced by a emerging black hole? So as far as we know, the speed of gravity is the same as the speed of light, which means gravitational waves will propagate through space at the speed of light. There's still some argument on whether or not it might be a little bit slower, but it's not faster. Yes, Larry, Fraser's open space is the same time as daily space tomorrow. Mistakes were made. Mistakes were made. Thank you for the bits, Wayne. Come here. Come on up. Hi. I know. You really want this. You really, really want this. So for those of you who are new, we thank you for your bits by giving the doggy dog treats so that you can experience the full cuteness of the dog. More bits. Thank you, Trekker Kev. This is Eddie. He is one of the 3 dogs in our house. Stella is our other dog, and we have a foster dog with us, Malachi. Come on up. Yeah. Oh, I know. You're going to move the desk. This is what you do. The desk is on wheels. You're so cute. You want that? Okay. Here you go. So, Eddie is my baby. All 3 of them are rescues. Okay. Can you get down? That was so sad. Okay. Eddie is a sweetie. Okay. So there's questions about glaciers. This may be referencing Yesterday, there was news coming out of Italy that it is feared that the Mont Blanc glacier, with a name this long I can't pronounce, is getting ready to collapse. And they have actually evacuated communities along the base of the glacier. Um, so, yeah, that could happen. Yeah. So, Waning Scott, I mentioned the three black hole galaxy merger just a few minutes ago. Um, I'm sorry. You guys are discussing the word glacier in multiple languages. That is fair. That is fair. So the three black hole merger, it's just a standard geometry that's pretty rare and hard to find, where we know that galaxies, they merge. It's how they grow. It's a standard thing. Our galaxy is currently eating a number of little tiny dwarf galaxies. It's what galaxies do. But finding a system that has three central supermassive black holes during the process of a merger is one of those things that we haven't really caught very often. And so this is a super cool little paper put together on these observations. It's always cool to find new things. So Just for Must is asking about the speed of light being broken. As far as we know, there's no mechanism by which you can explain something going faster than the speed of light. It is possible for things to have a wave. Eddie is moving my camera. I am so sorry. It is possible for waves to change their distribution in a way called tunneling. So electrons can jump from one energy level to another. And this tunneling is effectively a way of jumping from one place to another, but actual motion from one place to another, there's simply no mechanism for it to go faster than the speed of light. Now, there are lots of theories that look at ways to travel through other dimensions than the standard 3+ time that we observe. Yes, Eddie is hurting the camera. He's trying his hand at directing. At least I don't think he managed to move the camera so that like green screen bits are being revealed. So he was good that way. Oh, I love looking at how you're all making fun of my dog. He deserves it. He really does. Okay. Are there other questions out there? Maybe he should try a traveling. He's fine where he is. He has a good life. He kind of doesn't do cars very well. I'm not going to get Eddie a steady cam because Stella, the other dog, would just steal it. So Falco is asking, wasn't there a project for us mapping glaciers? Yes, we need to write the software for it. So that is coming. One of the things that we're dealing with around here is we went from having 3 full-time programmers to 0 full-time programmers. And this means that since no one is currently paid to work on the software for the project, and we're all doing it as volunteers, everything goes very slowly, very slowly. I'm in the process of applying for grants to try and change that. You didn't miss it. Just everything is going slowly. Yes, just for must. Theory means it's already been thought about. So theory has multiple meanings. It's actually a really problematic word. Theory, little t, means it's not a closed topic. Theory, capital T, means it's a closed topic. We are bad with words. This is why we are not people who work in words. Um, sorry for the confusion. Other things coming up before I move on and go record the podcast version of this show. Next week, I will be flying out to Tucson, Arizona. Annie will be here filling in for me on Tuesday while I'm on the airplane. While there, I am going to be doing a public talk at the Flandrell Center in Tucson, Arizona on Saturday, October 5th at 7 p.m. This is open to the public. This is part of our International Observe the Moon Night celebration. So if you're in the Phoenix, Tucson area, come on out and catch this free talk. I'm going to be talking about how impacts have shaped, well, worlds all around our solar system. Beyond that, other things that are coming up in November, I will be attending QCon in San Francisco. In December, Susie, Annie, and I are going to go catch the launch of a Falcon 9 and bring it all to you live as best we can. In January is the American Astronomical Society meeting, and this year it will be in Honolulu, Hawaii, and I do plan to be able to attend. There will be meetups associated with all of these events, so stay tuned to learn more. Looking to see if any more questions have come in. Wanging Scott, regarding asteroid deflection, this is it's a field of current study that's in a state of, asteroids aren't structured the way we thought. If you have a nice solid asteroid, it's easy to deflect them by either hitting them with something small that doesn't break them, by putting engines on them, all sorts of things like that. But what we're finding is more and more of the asteroids we look at are rubble piles. And if you hit a rubble pile, it just kind of rearranges itself a little. And so it looks like we're going to have to consider different techniques for how to deal with and deflect asteroids of different, structural integrity. And the way we deal with rubble piles and the way we deal with solid objects probably won't be the same thing. It's cool to be watching science change. If you're talking about the DART mission, this is a spacecraft that is going to be looking at a pair of asteroids and working to deflect, I believe, one of the two. This is a mission currently being funded out of the planetary defense part of NASA, where we're defending ourselves from space rocks. And that mission, DART, is going to be launching in the next few years. I don't remember the exact date. In general, spacecraft are dead to us until they have successfully launched, because until that happens, they can be canceled by NASA, canceled by Congress, canceled by the president, or canceled by technological failures and rapid, explosion. Explosions happen. Looking to see what else is in here. Hello, T-Girl 2 Beakers. I don't think I've seen your name before. Welcome. I think you have it right for the 2023. Oh, there are more bits. Eddie knows what that time means. Welcome, first timer. You're always welcome. Hi. So we thank you for your bits with the cutest thing around, which is this doggo. His name is Eddie, and today he is all about moving things around. I know. You know that there's another one. There you go. Sorry for the dog slurp noises near the camera. I know. You can go away now. He's like, dang it. Okay, fine. Yes, doggos. Doggos are required. Yes, there are up to 3 doggos on stream. Just one today, though. And it's great to see all those emotes out there. And I know, thanks to September, a whole bunch of you out there have emotes. So use them generously and freely, and spread science everywhere you go. So Reps Matt comments, I read NASA's planetary defense budget has grown 1,000% in 10 years. Yeah, it's also just getting more and more attention and getting pulled into one area of NASA. So one of the things that we talked about earlier this week was there had been a mission called NeoCam that was being led by Amy Mainzer as a science mission to study near-Earth objects. And this mission received funding in 2010 and 2015, but their 2016 proposal to build the spacecraft slated for a 2021 launch was denied. And then earlier this week, NASA Associate Administrator Thomas Zurbuchen announced that a NeoCam like mission, building on the plans and technologies developed by Amy Mainzer's team, would now be led out of NASA's Jet Propulsion Laboratory and funded out of the planetary defense budget. So here what we're seeing is something that was originally designed as a science mission is now getting resurrected and reclassified as a planetary defense mission. So in some cases, what we're seeing is funding that had previously been other places in NASA is getting pulled in to the new planetary defense budget. Okay, just for must wrote a long thing. I've heard of the heavy element on Earth cannot be produced by supernova, maybe by a neutron star. If considering many conditions and mostly the time, is there any heavy, dead old star near our solar system local group of stars? I'm interested to know the source of such things like uranium and heavy elements. So the catch is that we're not worried about where things are now. We're worried about where things were the 5 billion years ago when our solar system and all the other stars that are brothers and sister stars formed. Our star orbits our galaxy about every 250 million years. And objects that are a little further away orbit a little slower, and those are a little closer in form a little bit faster. And because of this relationship between distance from the center and orbital velocity, the cluster of stars that we originally formed as part of has now been completely disrupted. And so that group of stars all originally formed out of one cloud of material. And that cloud of material had ingredients that came from prior generations of supernovae, from prior generations of neutron star mergers, from just stars like our sun that died and poofed off their outer atmosphere that was enriched with other heavy elements. So it took many different generations of stars all giving up their atmospheres and either poofing things out, exploding things out, or otherwise just releasing their materials to outer space. All of that stuff enriched that cloud that our star system formed from. Now, we can't in any way find that stuff now. We can't go back and identify the supernova remnant, none of that. It's just too far in the past. So it's by looking at systems that are forming today that we can figure out what happened 5 billion years ago when our solar system came into being. I hope that helps. For a lot of things like this, a good resource is to check out the podcast that I do with Fraser Cain, Astronomy Cast. We've been recording for 12 years. We're in our 13th year right now, and we've done deep dives into a lot of these different topics. That is a really good resource, One Girl, Two Beakers. I remember using that resource when I was a graduate student. DPI 209, I don't remember what the heaviest element produced naturally is. I just don't remember. So 1000% growth is 10 times more than what it was, I think. 100% growth means you've doubled it. 300% growth gets confusing depending on context, because it could either mean you have 3 times what you had before, or it could mean that you have what you had before plus 3 times as much. Language is trickstery, which is why we often have to write the numbers out instead of just saying how many times more we have. Stupid language. Yeah, Falco Online, 12 years already. We started recording back in 2006. Okay, so I hope that I answered all your questions. Thank you so much for the follow, One Girl, Two Beakers. That's awesome. Thank you. It's always good to have another science type around. Okay, so I think that's all we've got for today. For those of you who are new, welcome. We bring you the daily space most Mondays through Fridays at 1 p.m. Eastern, 10 a.m. Pacific, which is 6 p.m. London time. On Sundays, Annie Wilson, who's my co-host, she brings you the Sunday Science Hour, same time, same place. We also co-stream Astronomy Cast, which will be occurring tomorrow at 3 p.m. Eastern, noon Pacific. That is 8 p.m. London time. And on Wednesdays, we also bring you the weekly Space Hangout. And when it doesn't conflict, we also bring you the Open Science by Fraser Cain. We are a place to learn and do science. We are associated with the CosmoQuest.org website, where we've been working to map out the asteroid Bennu at bennu.cosmoquest.org. We're a production of the Planetary Science Institute, so we are more than just this stream. We are actively working to explore our solar system and beyond. This show is produced by Susie Murph, and if you ever miss an episode live, you can go catch them over on YouTube, youtube.com/c/CosmoQuest. And we're here thanks to the generous bits, donations, subs, and patronage over on patreon.com/CosmoQuestX. So we're super grateful for everything you guys do to keep us going. And I'm going to, for absolutely no reason, give my dog another treat because he's cute. Come here, baby. Do you like this idea? Oh, you do. Okay, here you go. He's just like, yes, I will eat all the treats, all of them. Hi. I know. So next week, Annie will be doing the streaming on Tuesday. There's another follow. I can't see the name from here. Oh, Eddie didn't come in the video? Okay, let me see if I can get him in the video. New font strange. There's a new font. Oh, thank you, Daddy Cupcake. Okay, so the not in the video. I have no clue if you're talking about my dog. Oh, you are talking about my dog because he moved the camera. Hi. Do you want this? There you go. Okay, now the dog is in the video. Whoa. Yeah, chemistry labs are probably too gnarly for dogs. Astronomy, dogs are actually good. When I worked at Harvard, I was using the campus observatory at one point, and Harvard lets you take your dogs to work. And I had my large mutt with me. And when someone decided to try and join me in the observatory in the middle of the night, my dog scared the bejesus out of them. And they took off like a bat out of hell, which is a behavior I approve of completely. Yeah. Dogs are useful. They're also useful when you're observing and wildlife joins you. but most observatories actually have cats rather than dogs because mice is a real problem. Anyways, my dogs are awesome. Falco. So there is unfortunately a minimum size to which I can break the treats, at which point Eddie stops trying to eat them. This is why I have dog treat dust all over my desk right now. Let's see. Okay, so I'm going to go ahead and I'm going to see if I can do the roll the credits thing. We are then going to raid Oh Bother, and I am going to go record our podcast, which, if you can subscribe, would make me super happy. You can find it as The Daily Space in any podcatcher you like. So, as always, I'm Dr. Pamela Gay, and I am here to put science in your brain. We are produced by Susie Murph. We are a production of the Planetary Science Institute. And if it's not me, it's Annie Wilson hosting this channel. And we also get help on our co-streaming from Paranor. We're a group production, and we are made possible by you. If you want to learn more, check us out on patreon.com/CosmoQuestX. And wherever you are in the world, have a fabulous morning, evening, afternoon. And remember, we all share one sky. So get outside and look up. Bye-bye.